This is a lesson for Chapter 9, Section 2, titled Quadratic Functions. And we've got a couple different types of problems we're going to see today, so let's take a look at them. So here we have a quadratic function in the function notation, and it's negative 3x squared minus 6x minus 8. So what we learned yesterday is the general form for a quadratic is in this form: y equals ax squared plus bx plus c. And so y is the same thing as the function of x, if we want to use that notation. So what we're going to do first is find that axis of symmetry. And the axis of symmetry is that line in which you can end up drawing down the middle of a parabola that will cause it to cut in half. And so if we cut it right along that, it would line up perfect. The parabola on both sides would line up perfectly with each other. So it is this: axis of symmetry equals x, because it's a vertical line, and it is negative b over 2a. So we're taking the b term, taking its opposite, and then dividing it by double the a term. And that's going to give us that axis symmetry. Then we're going to substitute that value back in for x to find out what the y component of the vertex is. So let's try it. So we've got our a term right here and our b term right here. So x equals negative b, so the opposite of negative 6 over 2 times by negative 3. So the negative signs will cancel here, but we still have 1 left in the denominator, so it's 6 over negative 6, which makes negative 1. So that's the axis of symmetry. Let's go ahead and substitute it back in to find out what the y component is. And so it's going to be negative 3 times by negative 1 squared, and then minus 6 times by negative 1, and then minus 8. So when we do the work here, we end up with negative 3, and then the two negative signs cancel here, so we end up with positive 6. And that's what we're going to see when we're coming up with the vertex. Is you know you're doing something right if these two are opposite in sign and one is double the absolute value of the other. And so 6 is double absolute value of 3. And so this ends up giving us positive 3. Minus 8 gives us negative 5. So we've got our vertex. It's negative 1 comma negative 5. So this is the vertex. This is where we're starting. And so I'm going to go ahead and sketch in a coordinate plane. And once I find out where the vertex is, that allows me to figure out where I should put my x-axis along here. I need to have enough room to be able to fit it. I know it's a negative opens down. This tells me right here it's going to end up opening down. And that tells me I better have the x-axis pretty high up. So I'm going to just go 5 spaces down. So 1, 2, 3, 4, 5, and that way I'll be able to fit my vertex on there. So that's the maximum value. So over 1 to the left, up 5. 1, 2, 3, 4, 5. Yes, I did it right. So there it is. So now I can use the parent graph. The parent graph works this way. So if you plug in numbers for x, and we're not going to plug in 0, just going to plug in 1 and 2. And then we're going to triple that value and then take its opposite also, and again squaring the input. And so you're going to plug in 1. It doesn't matter whether it be negative or positive. When you square it, you get the same thing. Times by a negative 3 tells us to go down 3. So this is the y value from vertex. So from vertex when you end up doing this. And so over 1 tells us to go down 3 spaces. So you can see how steep this is, or how narrow this graph is going to be. So if you square 2, you get 4 times by negative 3 gives us negative 12. And so if plugging in 2 gives us negative 12. And so from the vertex, always from the vertex, over 2, down 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And again, there's going to be one right opposite of that axis of symmetry. And so it's going to go right there, and that gives us some points to be able to draw a curve through. So that's what we're seeing on that type of problem. Let's take a look at just one other example here. And what's different about this is we've got it opening up. And so right away I see this positive 2 tells me it opens up. And so I'm going to start with my a and b terms substituted into my axis of symmetry formula. So the opposite of b, so I got that opposite of negative again, over 2 times by positive 2 this time. So 6 over 4 is what I have there, so this makes 3 halves. And so I've got a fraction to deal with. That's okay. Just noting what that makes, 1.5. Now I'm going to use the fraction form when I substitute in. So 2 times by 3 halves, quantity squared, and then minus 12 times by 3 halves, and then plus 19. So when I do this work, this makes 9/4, and the 2 will cancel out some of that, so write it over here, 9/4 times by 2. You can see how a little cross-canceling occurs there, so you end up with 9/2, and then minus, and then here some cross-canceling occurs, and we're left with 6 times by 3, which gives me 18. So let's make sure we've done things right there. So 3/2. Now I knew I made a mistake in here somewhere, and where I ended up making it is right in here. I took half of 12 for some reason. So I knew I made a mistake because I always remember, as I said before, you know you're doing something right if you find that you've got opposite signs, which I was going to have opposite signs here, but I did not have one double the absolute value of the other. So I knew that right here because this makes 18, and 9/2 is not half of 18. So I made the error right here, so I'm going to go ahead and fix that and erase all of this work here and then start over. So here it is. We've got I'm going to go ahead and erase this part as well. And so it looks like it's going to end up being 12/4, and so that makes positive 3. So I don't have to deal with the fraction in this case. So I go ahead and substitute in 2 times by 3 squared minus 12 times by 3, and then plus 19. So when I do that work, 9 times 2 gives me 18 minus, and then this makes 36. See, now I know I'm doing something right, because if I go ahead and, first of all, I have opposite signs, and 36 is double 8, or 18. I'm sorry, 36 is double 18, or 18 is half of 36. So this ends up giving me negative 18, which when I go ahead and add the 19, I get a positive 1. So here's my vertex. It is 3, 1. So I know I'm opening up, so I can go ahead and draw the x-axis kind of low on my coordinate plane here. Hopefully your line looks better than that. So I'll try that once more here. And I have to go over 3 spaces up 1. So I'll start down here. So over 3 spaces up 1, so it starts right there. And then I'm going to use that parent graph. So the parent graph this time is a 2x squared. And so again, the y values are going to always be from vertex. So you move in the y direction from the vertex. So if I plug in a 1, doesn't matter whether it's positive or negative, you square it, you get 2. And so over 1 from the vertex up 2 spaces. And then squaring 2 gives us 4, but then you've got to double that answer, and so that's going to be 8. So always from the vertex, over 2 up 8. So it's 2, 4, 6, and then 8. Puts us right there. And then again, opposite of that axis of symmetry is another point, and that allows us to be able to come up with points fairly quickly. So that's graphing quadratics. Let's take a look at some word problems here. And here's one where it says a punter kicks the football into the air with an upward velocity of 62 feet per second. So one thing I want you to notice is that every time they give us the velocity, that's going to end up being the b term right here. And that's what you're going to see. So velocity represents the b term. ax squared plus bx plus c. So this term right here is that velocity. So upward velocity tells us that it's going to open down in this case, because it ends up going up and then comes back down. That's where the negative sign comes in. Positive 2 here, this is the initial height. So right here, so this is initial height. So what that means is the ball was 2 feet above the ground when it was kicked. And so what we want to do is we want to find out what is the maximum height of the ball. And so how high does it reach? Well, if we just think about what the graph looks like, if we just sketch a coordinate plane here, it would look something like this. We would have, and I'm going to move that over just a bit. It would do something like this. We'd go ahead and we'd have height here, and we'd have time here, and it starts 2 feet above the ground, and it comes up, and then it comes back down. And so right here, this is the vertex. That's going to end up giving us 2 parts of this problem here. It's going to give us, first of all, the time to maximum height. Time to max height. And then it is going to give us the maximum height. So the y value is the maximum height. So I'm going to find the time to the maximum height. They actually ask for what the maximum height is first, and then how long it takes to get there. So we're going to end up doing that in reverse order. We're going to find the maximum height first. So we've got negative b over 2a. So it's going to be a negative 62 over 2 times by negative 16. So we go ahead and do that work. We end up with 62 over 32, which reduces down to 31 over 16. So if I want to change that to a decimal, it's going to be about 1.9375, actually exactly that, seconds, and that's time in air, seconds for time in air. So now what we can do is we can find out what the maximum height actually is. So we can take that answer and substitute into the formula. And so here's a good calculator problem. And so we've got negative 16 times by 31/16, and we have to square that answer, and then plus 62 times by, and then 31 over 16, and then we go ahead and add the 2. So you can see how we can do it fairly quick on the calculator, and I've got one right here. And so if we go ahead and turn it on, and then just plugging in those numbers. And so let me move this down a little bit so we can see what those values were. And so these are the numbers I need to plug in. So I've got, I'm going to go ahead and plug in negative 16. So negative 16, then I use that fraction button. And actually I need to get rid of the fraction first, so I'm going to put the 16 here. And you don't even need to put the multiplication sign, it already knows that, but we'll go ahead and put it in there. And then I'll enter in there 31, and then I've got to bring it over 16, and I'm going to square that answer. So that's going to be squared, and then we'll go ahead and write in plus, and then we'll do the same thing for the next one. So 62 times by, and then I've got the fraction, 31 over 16, and then I have plus 2. And so when I go ahead and do that work, it gives me this answer of 993 over 16. And that is, in decimal form, about 62.0625 feet. And so we'll go ahead and write that in there. So h equals 62.0625 feet is the maximum height. Now, what they're going to ask for is, they're going to ask about how long is this in the air for. They want this time right here. We know it took about, let's see here, it was almost 2 seconds to get up to the maximum height. That's what it was to get up there. So we know this number is going to be pretty close to 4. Not exactly 4, but pretty close to 4. It's not going to be exactly 4 because we started up a little bit higher than 0. It was kicked from 2 feet above the ground. So we want to find out what is the height, and so what we're going to end up doing is using that calculator again to help us come up with that answer. So we're going to end up going to the mode button. So let me bring the calculator back up. I'm going to clear that, and I'm going to press mode. And so when I press mode, I'm going to enter the table. So I'm going to press 3, and it gives me the function notation. And so I'm going to enter that function notation. So it's negative 16, and then I've got x squared. So alpha is this button right here. So alpha, and then x right here, the close parenthesis, and that gives me my variable. And then I'm going to square that. So I press the squared button, and then I have, let's see, it is plus 62. So plus 62 alpha x, and then we are 2 feet above the ground, so plus 2. So now it allows us to enter another function, but we don't need to. So then we're going to press equals again. And so I press equals again, and I end up getting the start. And we're going to start at, let's go ahead, since we know, again, this value is right about here. It's 2 seconds. We know it's going to be close to 4. I'm going to try going from about 3 seconds to 4 seconds. That's going to be my range. So let's try that. Let's start at 3 seconds, and then you press equals again, and I'm going to end at 4 seconds. And I'm going to try values of 0.1 to see if it has enough memory to do that. So it does. Okay, so let's see what it did. So basically it's giving me these heights. Now, remember how at 3 seconds we were past the maximum height. You see, 3 seconds, it's showing 44 feet above the ground. And then it goes down. And you can see how it's going down, down, down. and we want to find out when it will be close to 0. So we're looking for that number that's close to 0. So at 3.7 seconds, it's just over 12 feet above the ground. At 3.8, it's 6 feet above the ground. 3.9, oh, right there, it's 0.44 feet above the ground. And at 4 seconds, it looks like that number is negative 6 feet. Negative 6 feet above the ground. So now that doesn't make sense. It's not above the ground if it's negative feet. So that means it has already hit the ground at 4 seconds. So I'm going to go with, it's about 3.9, maybe 3.91 seconds. So I'm going to go ahead and use that number. So I'm going to say that the time in air is going to be about 3.91 seconds. I know it's a little over 3.9 and it's below 4, so that makes sense to me. So let's take a look at one other problem here. And this one asks us same sort of thing. It wants to know, it's this time talking about a disk being thrown in the air upward at a velocity of 20 feet per second. Notice that that is the B term here, and this is our initial height. So it was 5 feet, or 6 feet this time, initial height. It was 6 feet above the ground. So again, this is what it looks like. It's starting, this is my height, this is my time. It's starting 6 feet above the ground, it's going up, and it's coming back down. We want to find a few things. We want to find that maximum height, the time it takes to get there. So let's do that first. So we're doing negative b over 2a. That's going to give us the time to the maximum height. So time to max height. And so I go ahead and substitute that in. It's going to be negative 20 over 2 times by negative 16. So 20 over 32. Reducing that fraction gives me 5/8, or 0.625 seconds. That's how long it takes to get up there to the maximum height. Time to max height. So it didn't take too long, not even a full second. Max height. So let's find out what that maximum height is. We're just going to substitute that back into the formula. I use the fraction form, so negative, we're going to find out what that height is, negative 16 times by 5/8 squared, and then plus 20 times by 5/8, and then plus 6. And so we'll do that on the calculator. And so I'll go ahead and come up with that presenter here. And I'll bring it down just a little bit so I can see what's going on. Now I press mode again, and I'm going to press 1 for computation, and then I enter that number. So negative 16 times by, and then the fraction button, 5/8, and then I'm squaring that number, so I press squared, and then plus 20 times by, and then the fraction button again, and then 5/8, and then plus 6 for the initial height. And it gives me 49/4. Change that to the decimal form, 12.25. So we'll write that in there. H equals 49/4, which is 12.25 feet above ground. This is going to end up being the maximum height. Alright, so now we've got that. Now they're going to ask us for something a little bit different. How long does it take the disk to be caught 3 feet off the ground? Okay, let's do this. Let's take 3. We're going to put it in for h. Let's rewrite our formula here. Negative 16x squared plus 20x plus 6. Let's go ahead and move that 3 over. We've got to get h by itself. And now we've got this. Negative 16x squared plus 20x plus 3 equals h. So now we have a new equation. We're going to go ahead and plug that in. Find out about when it hits the ground. Now, 3 feet above the ground. Okay, here's 6, here's 3. So just looking at it, I know that it's going to end up, it took less than a second to get up there. It's going to be less than, just over a second. Maybe about like 1.5 seconds to hit the ground. That's my guess. Somewhere right around there. And so at 3 feet, I'm guessing it's going to be pretty close to 1.5. So I'm probably going to start, let's start at like 1.1 second, and then let's go to 1.5 seconds to find out where it's going to be. And if we need to zero in a little bit more, we'll do so. So let's go to the presenter, and let's go ahead and clear that. We'll do a mode table, and let's enter the function. So it's negative 16 alpha x squared, and then plus 20 alpha x plus 3.
And then we're going to do a start at 1, let's step at, or end at 1.5, and let's do a 0.1. And let's find out where we're at. Okay, so it has enough memories here. So at 1 second, it's 7 feet above the ground. 1.153, 1 foot above the ground. And actually, this is 1 foot above 3 feet. And then it's down below it. So it's between 1.3 and 1.4. So if we wanted to, we could go ahead and get a little bit closer. Again, we could have used the same equation, but this is just allowing us to figure out the closest to 0. Again, we would have done the same thing. We would have tried to find out when it's close to 3 if we had used the same equation. So it looks like it's going to be between 1.3 and 1.4. Let's try a 1.35 just to see what happens. So let's go ahead and press AC again. Let's press equals, and let's get it a little bit closer. So it's between 1.3 and 1.4. So I'm going to end at 1.4, and I'm going to do a step value of 0.01 this time. So now I've got a little bit closer. And when I go ahead and go down, I'm trying to find out, this is when it gets to 0, that's at 3 feet above the ground. And it looks like it's right about there between 1.38 and 1.39. So it's right in between those two values there. So we're going to go with that. It's in between there would be 1.385 seconds. I'll just go with that until it is caught at 3 feet above ground. So there we have it. So those are the types of problems you're going to see on tonight's assignment. Good luck.